And here we are again. Hello to the Partizia community and everyone else out there who might be tuning in to another Solution Spotlight series. This week, we are going to discuss RNG, which stands for a Random Number Generator. Um, this is something that many years ago, like there was philosophical discussions because one would think that computers would be able to just create a software and just randomly create numbers or whatever variable you'd like. But it seems that no, that computers do have this thing called bias, just like humans do. There are some very crazy. I'm not going to get into it because it sounds like woo woo, like voodoo or something like that. But there are experiments out there where just the intention of people can actually influence certain random number generators, which is kind of very weird to actually discuss in this call. We're not going to do it for sure, but if anyone has curiosity, just go out and these are true scientific papers that have been peer reviewed and replicated. So the sheer intention of a group of researchers to influence a random number generator has been shown to be a real thing, which is crazy, isn't it, Bruce?
Yeah, I was also very surprised at how difficult generating true random numbers are. I first heard about this issue in a video that Neil deGrasse Tyson did in regards to how difficult it actually really is to generate random numbers. And I was like, oh, come on, it can't really be hard. There's so many different ways of doing it. I can choose a random number off the top of my head. And and then I saw his video. I was like, oh wow, actually this actually is a pretty tough problem. And to your point, Tiago, he was basically saying, hey, one of the only ways of truly generating a random number is to take a look at the atomic decay of a element and and using that to as the actual real way to generate random digits or random numbers. And I was like, wow, this is pretty hard. So when I heard that multi-party computation can actually be used to help generate true random numbers, I was actually fascinated because random numbers are used everywhere. I don't think a lot of people may know, but your crypto wallets, their
Mhm.
private keys are generated using random numbers. And I think what we have in the industry is what they call like pseudo random numbers, which is generated through some level of like a structured code, right? And ultimately, because the code itself is structured, you can't really call that a random number, and there are issues around that, which we're going to dive into today. So I think today's call will be shorter than the other ones that we've done before,
Mhm.
but it'll definitely be potentially could be a very big eye opener for a lot of people. Okay, so why don't we jump right in? The topic of today's conversation is not just about generating random numbers, but it's also about unbiased and incorruptible random numbers through multi-party computation. And as we spoke, random numbers are everywhere. Cryptography is a really important use case. We talked about the games of chance, so things like gaming, whether it's video games or other types of games like games of like dice or coin flipping. Even it's used in research. It's actually used in machine learning,
Mhm.
statistics, simulations, and like we talked about, and when you generate your crypto wallet key, it is cryptography, and random numbers are used. And we've talked a little bit about how securing a secure random number generation is extremely hard. You have basically at a very high level, you have two problems. You have a predictability issue where when you generate a random number, you can predict at a certain level what that number is going to be. In certain cases, you can predict from a percentage perspective what's the percentage of a particular number versus another number. right? You have a predictability issue there. And then you also have like bias and corruptions issues, right? If somebody takes control over a random number generation, they can tweak it to their benefit. So we have those two different issues. And we're going to delve a little bit into the predictability issue. And so this was very new to me. I never knew that this actually happened, but there's something called a Benford's law, which I found to be extremely interesting, where when you choose a random number it's somewhere in nature, whether it's a book or whether it's in your mind, or you flip through a book and you choose a random number, or a random page, as an example, or you have years, from year 1 to year 2000, and you want to choose a random year from that year. When you do that, Benford's law states that the initial number, the first number in that random number that you choose, 30% of the time it's going to start with the number 1. 17% of the time it's going to start with the number 2. So in this way, you're not really generating a number that is truly random, right? Every number that you choose, 30% of the time, that number is going to begin with the number 1, right? And if you're really choosing a random number out of anything, right, you want every single number to have an identical percentage. But unfortunately, if you use our natural environment, because you're working with some sort of a subset of numbers, you will end up choosing a number that starts with the number 1 30% of the time, 17% of the time for number 2, et cetera, et cetera. So you have a certain level of a predictability issues when we start to choose random numbers. And then from a code perspective, we talked about now we have codes that are able to generate random numbers, but unfortunately, because when a code generates a random number, it is based on some level of a structured code that's based on rules. Yeah, you specify a particular type of a rule or a function or some sort of a computation that's generating a particular random number. And if you see the number often enough, you can actually reverse engineer that and find out what that equation potentially could be. And you actually have real world cases where you have people that has reverse engineered the code and was able to predict what the next number will be, or actually crack open the encryption code, as an example, right? There's a famous PlayStation 3 code that was cracked. It was like a random encryption that was being used, but because the code was weak and the algorithm wasn't strong enough, people who saw the random generation of numbers was able to reverse engineer that and then go back and crack the actual encryption code for PlayStation 3 accounts, right? So you have these predictability issues with random number generation. I think there was also another initial instance of a Bitcoin wallet actually in the beginning, potentially being able to be cracked. And if I can find that example, I'll list it on the menu.
Oh my God! You just reminded me. You just reminded me of something. Way back in 2014, when I was figuring out blockchain for the first time and everything was new to me, there was this wallet that was generated through the web browser, but you had to move your mouse randomly and it would record your movement on the XY axis, right? So it would record your movements, not a predetermined movement or whatever. And that was used to generate your wallet address.
Right. Yeah.
Well, I cannot remember what project that was or what blockchain that was, but I do remember that being a thing because I was like, oh,
yeah.
why do I need to just go crazy on the screen and just move it for it to generate? And then I understood that it's to create some true randomness, because algorithmically it's really difficult to create true randomness.
Yeah, and I think even that runs through some sort of a encryption algorithm, right? So even though you were moving around the mouse in a random way, that randomness then gets generated, that is being used on top of a generation equation, right? And then it creates the keys. And if you know what that equation is, then you can go back and actually crack the code, right? So that's the problem, I think, with the predictability issues in random number generation. I think I I'll link in in the comments or in the menu below with the examples of how some of these issues manifested itself. There's predictability issues, but there's also like bias and corruption issues in random number generation. So, one of the reasons why you want random numbers is because you don't want bias. You don't want somebody to have some sort of a bias in the numbers when they get generated. Because if there's bias, you run into things like corruption issues. You may take that number and use it to your advantage, or you're going to throw off any kind of a statistical model that you're trying to create to simulate some sort of an event, right? So you have a lot of these issues that come up with a bias and corruption issues in random number generation. So as an example, one of the ways you would generate a number is if, let's say a particular number of parties. Let's say in this example, we're showing 4 people, right? 4 people decides to choose a random number. And then all those random numbers then gets put into some sort of a function and does some sort of a computation or equation to come up with some sort of a random number, right? But let's say that, this is some sort of a system and let's say that I'm, R1, random number one, which is at the top right-hand corner. And I say, wait a second, these other 3 people are throwing in their random number and it's going through an equation. I've seen what the results of those equations are. I'm going to hold off until I see the numbers from the other parties. And then I can choose whatever random number that I'm going to use and then throw it into the equation at the last minute after figuring out what the other numbers are so that I know what the random number is going to be once it's generated. So, you could do this to, gain bias or gain, some kind of a advantage over some sort of a situation. So you have that issue, right? You have the human corruption element where one person of the party can potentially manipulate, how the number gets generated. And then you have, potentially the other issue where all of these pseudo random number creation that is done by a code generally is controlled by somebody. So as an example, if you go into, you know, an online gambling site as an example, right? All of these different online gambling sites off source or offload their random number generation. This is online casinos, right? They generate their random numbers through some sort of a service. And there are many different services out there on the internet that they say, hey, I'm going to generate a random number on your behalf. But these are centralized systems. This particular company says, hey, I'm going to generate a random number. I'm not going to share with you people what the equations are because they're private, and so I'm not going to share with you how we generate the numbers, who is in control of the generation of the numbers. You'll just have to trust us. So you have to trust them to not manipulate the generation of the random numbers. And the other issue is that perhaps a hacker or hackers can go into the system, hack into the system, and manipulate how these numbers are generated, and then create a bias into the system that these random numbers are being generated for. And also, again, if you know the actual pattern, if you know the secret sauce behind how these random numbers are generated, you can actually reverse engineer to actually get to the number itself or actually predict what the next number could be. So you have all these different bias and corruption issues in random number generation. So how do we create a unbiased and incorruptible random number generation? And one of the ways that you can do it is through multi-party computation. So the way a multi-party computation will be used to generate random numbers is through secret sharing. And we reviewed the secret sharing aspect of it in our private voting video and using Shamir secret sharing, right? And the concept is very similar. And so what we're going to basically say in this example is that we have 4 players in the system. And these 4 players are going to generate random numbers. And now, in the beginning, we talked about the fact that if there was somebody who wanted to corrupt the system or to create a random number to benefit themselves, they can hold out, right? But what we're going to do in this case is that every one of these players, when they submit their secret, or when they submit their random numbers, it's going to be in secret. Just like how we do it with any other secret sharing using multi-party computation. And so player 2, player 3, player 4 in the system submits their random numbers, but it's in secret and it goes into the system. So this means that player 1 who wants to cheat the system is ultimately unable to because they can't see what the random number itself that any of the players submitted to generate the random number. And so because, in this case, because Bob is unable to see what's actually going on in there, he either has to submit his value or he may choose not to, Either way, these numbers, which is private and is in secret, goes into multi-party, into our system, into the MPC system. It then breaks open or it computes using MPC to generate a random number through some sort of a function. All right. So at a very high level, this random number generation through MPC can really help eliminate both the predictability issue as well as the corruption and the unbiased issue in random number generation.
So, wow, yeah, random number generation. It's such a sensitive topic to so many industries because, as you said, they had this need for something truly random, but randomness is incredibly difficult to achieve. And so yeah, I mean, there's so many use cases for RNG that it's incredible that now with MPC technology on a public blockchain, you don't have to rely on services like you mentioned before. Like, for example, the casinos, if they own the process of random number generation and someone hits 20 times black on a roulette, they might say, these guys are cheating. Right? When in reality, statistics tells you that it's absolutely probable that sometime there will be 20 times that black is going to come out instead of a red. So that's why casinos outsource these services. Now, anyone out there, but as you mentioned, that service can be corrupted as well. Right, by hackers or by interests. So now on a public blockchain, anyone can use the Partizia blockchain infrastructure to guarantee that their randomness is not biased and it's not being manipulated by any party.
Yeah, and I think that's a really good point that we didn't discuss earlier, which you're bringing up now, because it is on a public blockchain, and we are able to layer on top some level of a governance around it. So things like even audits, things like we need to see the actual numbers to verify that this was done in a legitimate way. And we can do that.
I think this concludes this presentation. I would like to thank everyone who's been with us all this time to keep on participating in these sessions. And if you have any follow-up questions, please drop us a line. If you have any ideas or any questions regarding how you can integrate random number generation into your project, or uh, anything that you may need, just get in touch with us. Go to Discord, go to Telegram, and request to talk to one of the admins or with us directly, and we'll be more than happy to take this conversation further. And yeah, stay tuned, because we do have more of these series coming up. So thank you very much for attending, and bye bye everyone. See you next time.
Yeah, thanks, guys.